On my daily quiz questions, which you can access by following me on Twitter or connecting with me on LinkedIn, I asked this question. Which devices receive the frame in the Wireshark capture and why? So here's a topology consisting of a single switch and 4 PCs. If we captured a frame on this link, in other words, the link between PC 1 and switch 1, and that frame looked like this, how would traffic flow in the network? Notice the IP address, 239.1.1.1. Source MAC address is this, so 0000C111111, and if we go back to the previous picture, that's PC1. How would traffic flow when this frame is sent from PC1 to this MAC address or this IP address? Where would the traffic go? So what do you think? If you want to try and work it out, pause the video at this point. Once again, here's the frame. And if I go back, here's the topology. Very simple topology consisting of 4 PCs. PC1 is sending this frame into the network. It's a multicast frame. Notice this is a layer 2 switch. How would the frame be sent by the switch? So to practically demonstrate the answer to this quiz question, I've built the topology in GNS3. I've got 4 PCs, PC1, PC2, PC3, and PC4. I've got them configured with IP addresses and MAC addresses, and I've got a switch. Now, to make it easier to demonstrate technologies, I'm using Cisco routers here. So rather than using Linux or Windows, I'm using Cisco IOS V routers as the PCs. So they're running Cisco IOS V software, 4 routers acting as PCs. One of the reasons I want to do that is I can simply configure the MAC address under the interface as follows and configure the IP address. I can also send IGMP multicast packets into the network very easily using a Cisco router rather than having to configure stuff on Windows or Linux. So that's what I'm using here. 4 Cisco routers are acting as our PCs. Okay, on this switch has almost no configuration. So show run pipe include IGMP shows us that no IGMP messages are displayed. One of the first things I want to do is disable IGMP so that you can see the behavior of a standard layer 2 switch. So I'm going to type no IP IGMP snooping. Now, if you're not sure what IGMP is Internet Group Management Protocol. It's a way, for example, for PCs and routers and switches to communicate and learn about multicast memberships. As an example, by default, no one's going to reply to a multicast packet if they're not subscribed to that. And I can demonstrate that quite easily in this GNS3 topology. So as an example, if PC1 pings PC2 using a unicast, we get a reply. If I ping PC3, we get a reply. But these are unicast packets. If I sent a multicast, so pinged 239.1.1.1, notice we don't get a reply. There's a timeout here. And if I sent 5 packets as an example, there's going to be a timeout. IGMP is important when hosts want to join multicast groups and routers want to forward traffic to hosts that have subscribed to multicast groups. So as an example, on PC3, I'm going to go onto the gigabit 00 interface. That's this interface on the PC. So I'll just add those interfaces to the topology. So that's this interface on the PC. I'm going to say IP, IGMP, and notice there's this option, join group 239.1.1.1. I'm going to press enter. And now, notice the difference. On PC1, if I send a single ping to 239.1.1.1, I get a reply from PC3. PC3 has subscribed to that multicast group, so it's replying back. With multicasts, devices will only listen into and receive traffic once they've subscribed to the multicast group. So PC2 and PC4 are not subscribed to the multicast group, so they don't reply. But what I could do is go into PC2, go into gigabit 00, type IP IGMP, join group, and the group I want to join is this group. So now we should get a reply from both PC2 and PC3. So let's do that. Here's PC1 pinging that IP address. Notice both those devices reply. PC4 doesn't reply. Now, to go back to our original question, I'm going to unsubscribe from that group on both PC2 and PC3, so they are no longer part of that IGMP group. So back on PC1, when I ping that multicast address, notice no one replies. But what actually happens with the traffic if this is a pure layer 2 switch? So on a layer 2 switch, we haven't got IGMP snooping enabled. I've disabled it. Show VLAN. And notice here, all ports on this switch are in the default VLAN of VLAN 1. What's going to happen when PC1 sends a multicast frame to the switch? Will it be flooded out of this port, or this port, or this port, or out of all ports, or will the traffic be dropped? What's going to happen to a multicast frame sent by PC1? So to see what happens, I'm going to start Wireshark captures. Here's PC2. Here's PC3. And here's PC4. This is the link to PC2 as an example. We can see spanning tree messages sent by the switch as an example. We can see CDP, VTP messages sent by the switch. I'm going to filter for ICMP. We see no ICMP messages at the moment because I started this Wireshark capture after sending my ICMP packets, so none are displayed at the moment. So I've got 3 Wireshark captures. This is PC4, here's PC3, and here's PC2. So back on PC1, what happens when I send a multicast frame to this IP address? We get no reply, so no one is replying, but notice the multicast packet was received on the link to PC2. There's the source MAC address, there's the destination MAC address. So this was flooded by the switch out of port gigabit 01, which is the connection to PC2. So it was sent out of here. What about PC3? We can see the same multicast frame. So it was sent by the switch out of gigabit 02 to the PC. Notice source MAC address, destination MAC address. MAC address has been derived from the multicast IP address. And PC4, search for ICMP or filter for ICMP. Notice we see the same multicast traffic. So the frame that was sent by the PC to the switch has been flooded out of all ports on the switch. Now this is important to remember. Broadcast frames, unknown unicast frames, and multicast frames are flooded by a layer 2 switch by default. Remember, I disabled IGMP snooping. IGMP snooping allows the switch to listen in on IGMP messages and then forward multicast messages or multicast packets only out of interfaces where there are subscribers to the multicast. At the moment, there are no subscribers to this multicast. That's why there are no replies to the multicast ping. But the packets are still flooded out of all ports. Notice there's the second packet. on the link to PC4. Here's the second packet on the link to PC3. And here it is on the link to PC2. Even though there are no subscribers to the multicast, a layer 2 switch by default floods multicast packets because it doesn't know where to send them. It simply forwards them out of all interfaces except the interface on which it was received. Okay, so that is the answer to the question. Which devices receive the frame in the Wireshark capture? If the Wireshark capture was captured here, and this is the Wireshark capture from PC1 to the multicast address, the switch will receive the frame and then flood it to all PCs in the topology except on the link on which it was received. So it's flooded out of gigabit 01, 03, and 02. Now another question I asked is, who will reply? And I've kind of answered that already. No one replies to the multicast unless they've subscribed to the multicast. So at the moment, no one is replying. If I set PC3 to join that multicast group by using the command IP IGMP join group 239 1.1.1, it will reply to the ping sent by PC1. And notice there you go, it replied. So this PC replied to the multicast, and to prove the point, notice on PC3, show run interface gigabit 00, notice this MAC address, this IP address replied to the ping. And if we look at the Wireshark capture on that link, what you'll notice is there is the frame from PC1 to the multicast address. So PC1 is sending an ICMP message to this multicast address, and PC3 is now replying to PC1. This is a unicast ICMP echo reply. It's sent in reply to the original multicast ICMP echo message. So PC1 doesn't actually know who's going to reply. It sends the ICMP echo message to this multicast address. It doesn't know who's subscribed to the multicast, but anyone who's subscribed will reply back. So as an example, if we go to PC2 and get it to join the multicast once again, PC2 has this MAC address, this IP address, and has now joined that multicast group. When PC1 sends the ping, notice both devices reply. And what I'm going to do is try and show you the Wireshark messages in real time. So here's the two PCs. Here's PC2 as an example. Here's PC3. And what I'll do is ping that multicast. And hopefully you can see that PC1 sent the multicast and PC2 replied to that multicast. And if we look at PC3, there's the original ping. Here's the reply from PC3. So both of them replied. PC4 didn't reply because it's not subscribed. But also notice this. If I send a multicast to this address, neither of those PCs are going to reply because they're not subscribed to that multicast. So we see the original ping on the link to PC2, but we don't see a reply to that multicast because PC2 is not subscribed to the multicast, so it's not going to reply back. I could use a different multicast address, something like this as an example. We can see the original multicast ping from PC1, but we don't see the reply because PC2 is not replying to that multicast. PC2 is not subscribed to the multicast, but if we pinged the original 239 1.1.1, notice we get a reply sent by PC2 back to PC1. Okay, so who will reply? Devices that have subscribed to the multicast group will reply. PC4 doesn't reply because it's not part of the multicast group. Okay, so what happens if we enable IGMP on the switch? At the moment, once again, I've disabled IGMP snooping. So what happens if we enable IGMP snooping on the switch. That is the default on this switch. Notice when I type show run, include IGMP, we don't see any output because that is a default command. We can also type show IP IGMP snooping, and what you can see here is that IGMP snooping is enabled. Notice it's enabled on VLAN 1. An immediate leave is not enabled. In IGMP version 2, a host can send what's called a leave message to a multicast router to leave the group immediately and not wait for a timeout. But that's not really important for what we want to see here. What should happen is we don't see multicasts on this link, the link to PC4, because PC4 hasn't subscribed to the multicast group. So that was the last message that was sent. We shouldn't see multicasts on the link, but I'm going to warn you before I do this, it's not going to work. It doesn't work properly on iOS V, layer 2 switches. So it doesn't actually physically work here, but in theory, the multicast shouldn't be sent to PC4, but it is being sent to PC4 because of perhaps a bug or some other issue on the switch, or because it doesn't have ASICs because it's a virtual switch. Now on Cisco's website, they do have a document here. Multicast does not work in the same VLAN in Catalyst switches, and they tell you options such as enabling IGMP queries on a layer 2 switch or enabling PIM on a layer 3 interface. I'm not going to demonstrate that because I have tested these options on the switch and it didn't work in my tests. If you get it working, let me know, but it's something that I didn't get working in this version of iOS V layer 2 running in GNS3. So in theory, the packets shouldn't be sent here, but they are, even though IGMP snooping is enabled. For the exam, if IGMP snooping is enabled on this switch, multicasts will not be forwarded to PC4. That's what should happen in the real world. The reason why is because PC3 and PC2 have subscribed to this group. And what I want to show you here, it's a nice option in iOS, debug ICMP, or debug IP ICMP rather. You can actually see the multicast packets arriving on the routers. Debug IP ICMP. Notice PC2 has subscribed to the multicast. We won't see that on PC4. In other words, PC4 won't reply to the multicast, but the packets are sent along this link, and we can see that using Wireshark. So notice now on PC1, and I'll just show PC2 here so you can see the output. On PC1, if I send one multicast ping, notice we see the reply sent back to PC1 from PC2. So we can see source is PC2, destination is PC1. We'll see something similar on PC3, notice there. These are routers once again, but I'm using them as PCs in the topology. PC4 doesn't show any ICMP messages because it's not accepting the packets. So when the packets hit the router, it basically drops them. The packets are being received by the router, and we can see that in the output here. Notice we're getting additional pings. So the pings are being received on the link to PC4, but the PC, or in this case the router, is not replying because it hasn't subscribed to the group. But the other PCs, such as PC3 and PC2, are replying to the multicast. Okay, so that was quite a bit of multicast theory and practical demonstration of multicast. I really like using Cisco routers for multicast testing because you can run commands such as debug IP-ICMP, you can ping the multicast group, you can get the routers to join the multicast group, you can actually see what's going on. Now, I hope you enjoyed this video. If you did, please like it. That really helps me. And please, if you don't mind, subscribe to my YouTube channel. That really, really does help me. I'm David Bombal. Want to wish you all the very best.